Hello and welcome. In this video, we're going to calculate the total parallel resistance of this circuit. So this circuit is a parallel circuit because of the nodes that it has across the top. We see that this has multiple pathways for current to flow. It can go down through R1, it can travel down through R2, down through R3, or down through R4, and then they all come back together at the bottom to create our IT. So we actually have 5 different currents in the circuit. We have IT, I1, I2, I3, and I4, and each one of those will be different, right? So we can solve for each one of those independently. So keep that in mind for parallel circuits. So we are going to apply our total parallel resistance here. So we want to identify the relationship of this circuit. We just found out that each one of these had a node across the top and made them in parallel with each other. Right? We can write that out in a parallel equation using the relationship. So we can say that we have R1 in parallel with, that's that double bar that we use in geometry classes to identify when two lines were parallel to each other. We can use that here to represent the relationship of our parallel equation. We can say R2 is in parallel with R3, which is in parallel with R4. Right, so now we know that all of them are in parallel. We can just plug them directly into our parallel equation up here, and that's going to solve out for it. So watch out for this one. We want to make sure that all of our notation matches here. To make this easier on us, we can say, let's put all of them into kiloohms, because most of these are already in kiloohms. We can see that here, but one of them is not. Right? So make sure that you have your notation either added into the equation here, because we could just write it in as 1000. We can move all of these down to our base location, right? Or we can move the 820 into kiloohms, and that would be the same thing. So let's do that. Let's take our 820. And we'll put it into kiloohms. We're at base right now, 0. And we'll move that forward 1, 2, 3, and put our decimal point there. So now we have 0.82 k ohms. Now that they're all in kiloohms, we can just plug them directly into our equation over here. We can say 1 over 1 over, and this is going to be our R1 value of 1 kiloohms. We're going to leave the kiloohms off because they're all in kiloohms. That means we know our answer will be in kiloohms. We'll go over key 1 and say plus 1 over 2.2. That's in kiloohms. We're going to leave that off. Plus 1 over 0.82. That's also in kiloohms, so we'll leave that off. We'll add that to our 1 over 1 kiloohm also. And we get an answer that's in kiloohms over here. So now we have a value for RT. RT is equal to 0.272 k ohms. We can round off the rest of that. We don't need the rest of it there. We could just move our decimal point back because this is a really small number for kiloohms. So we could move it back 1, 2, 3 back to our base location from our positive 3. That gets rid of that kiloohm value, and we're left with 272 ohms. All right, let us know if you have any questions.